Okay, looking at today's do now, we have two problems. The first one asks us to solve an equation for h. When we look at this equation, we clearly see that we're going to have to simplify it first. To simplify this one, it's as simple as combining our like terms. We have 3h plus 6 is equal to 12. And now we've got a two-step equation to solve. 3h plus 6 plus negative 6 is equal to 12 plus negative 6. This adds up to 0, leaving us with 3h is equal to 6. Divide both sides by 3, and we are left with h is equal to 2. That's answer choice A. Coming over here, we look for which equation or equations represents the situation below. You have $28 to spend at the iTunes store. You spend $4 on a game for your phone, and you want to spend the rest on songs. The song costs $1.50 each. How many songs X can you buy? So we're looking at this. We have $28 in total to spend, so our total cost is going to be $28. We've spent 4 of that on games, so $4 plus the rest of it will be spent on songs. Well, songs are $1.50 times however many songs, so 1.5 times X. And looking through this, I'm looking for one that matches this. I only have one where we've, okay, so this one's got the coefficient on the X term, this one's got the coefficient on the X term. One where we have 4 added to the 1.5x, that's answer choice D. And just thinking through this, making sure none of the rest of them would also make sense. In order for us, once we add the negative 4 to both sides, that would have the 28 and the 4 subtracting from each other, so that's definitely not going to be right. And if we were to move the 1.5x to the other side, it would also be negative, so that's not going to make this answer choice right either. So we got answer choice D. Let's flip on over and look at our aim for today. Alright, today's aim, we're going to write and solve equations from word problems. Alright, so this is really pretty much the same aim as yesterday. We're just going to be looking at more problems, giving us more experience, more examples to look at. Alright, so we have Julia, Keller, and Israel. They're all volunteer firefighters. On Sunday, the volunteer fire department held its annual coin drop fundraiser at a streetlight. After 1 hour, they had collected $42.50 more than Julia. So this is Keller has collected $4. Israel had collected $15 less than Keller. The three firefighters collected a total of $125.95. How much did each person get? So this is very much like our sister's problem the other day, except for instead of being told that we have consecutive amounts here, we're told the relationship between the amounts. So the amount of money that Julia collected is J dollars. Write an expression to represent the amount of money that Keller collected in dollars. So we want a representation in terms of J. So when I look at this, I'm looking at this relationship between Julia and Keller. So if Julia made J dollars, Keller collected more than she did. So Keller is going to be J plus $42.50. All right. Using the expression for Julia and for Keller, write an expression to represent the amount of money that Israel collected in terms of dollars. Alright, so we know that this is Keller now, J plus $42.50, and we know Israel collected $15 less than Keller did. So we want to take Keller's expression and we want to do what with it? Obviously, you're sitting here thinking we want to subtract 15 from it. So what that looks like as an expression is J plus $42.50 minus 15. Alright, so we're going to use all the expressions above to write an equation in terms of J that can be used to find the amount that each person collected. So when we look at this, the equation we're going to read back and we see that the total that collected is $125.95. So that's definitely going to be what our equation is equal to, and then we're going to be summing up the total value. So much like I did yesterday, I'm going to think about this as a pseudo equation first, where I'm going to be thinking about this as Julia plus Keller plus Israel is equal to 125.95. Now I can start plugging what I know. Well, we said Julia is just going to be J. So here we have J. And we said Keller, that's this expression that we wrote right here, is J plus $42.50. And Israel is this expression, J plus $42.50 minus 15. And all of this, the total, when I add all of them together, is $125.95. So there's our equation. Go ahead and solve this equation. In order to do that, you're clearly going to have to be doing some simplifying of this equation before you start doing some solving. Alright, so you should be pretty far ahead. You probably should have finished solving this at this point. If you haven't, go ahead and pause the video to make sure that you have. I'm going to go ahead and start. I'm going to start with this equation up here, and I'm going to go ahead and commute my like terms next to each other. I have J plus J plus J plus 42.50 plus 42.50. And we had a minus 15, which I'm going to change to add the opposite. And so that's going to be plus a negative 15. Well, it's still subtracting 15, but we just want to make sure that we've got it there in order to use our commutative property, $125.95. So looking over here, I'm going to go ahead and combine my like terms. The J plus J plus J we know is 3J. And the 42.50 plus 42.50 minus 15, well, 42.50 plus 42.50 is going to be 85. Minus 15 is going to give us 70. So we have 3J plus 70 is equal to 125.95. And now we can go ahead and start doing some inverse operations, starting with the inverse of our addition. 3J plus 70 plus negative 70 is equal to 125.95 plus negative 70. So we have 3J plus 0 is going to be equal to 55.95. So thinking about that, that's really just 3J, because adding 0, that's the additive identity. Divide both sides by 3. That's going to give me J is equal to 55.95, so 55.95 divided by 3. It's going to go in one time with the remainder 2. Bring down the 5. It's going to go in 8 times, which is 24. That's going to give me a remainder 1. Bring down the 9. Decimal pops up. 9 goes in 6 times. That's going to give me a remainder 1. 18, remainder 1. And 15 goes in 5 times. So we're going to get that Julia made a rocking $18.65. So now we can use that to find out what Keller was. Keller was $42.50 more than that. So Keller would be $18.65 plus $42.50. Doing some quick math there. We're going to get that is going to be $61.15. And Israel was 15 less than Keller, so that would make Israel equal to 61.15 minus a total of 15 whole dollars, which is going to give me $46.15. Now, if I wanted a quick check, I'd want to go ahead and add all of those up together to make sure that they do indeed add up to $125.95. Feel free to do that off to the side as a quick check on your own work. Alright, coming over here, we have a second problem. This is a more geometrical type problem. It says you are designing a rectangular pet pen for your new baby puppy. You have 30 feet of fence barrier. You decide that you would like the length to be 6 1/3 feet longer than the width. Alright, so one thing to think about it is what this 30 feet of barrier is all about. That means that when we make our pen, that our total perimeter, our total amount of fencing here is going to be 30 feet. And so that actually gives us a pretty good idea here that our total, when we write this equation, is going to be equal to 30 feet. Alright, so now we're looking at this. We have, we would like the length to be 6.5 feet longer than the width. So let's just call this the width. And we want this to be 6 1/3 foot longer. So this is going to be W plus 6 1/3 feet. We also need to label the other sides, because if we're talking about perimeter, we need to add all sides. So we're thinking about this as being a rectangle. We should know some particular things about opposite sides of rectangles. And hopefully you've already jumped ahead of me and already labeled these two sides. This one's definitely going to be W. This one's going to be W plus 6 1/3. 6 1/3. So coming over here, if I want to go ahead and do this, now I want the perimeter, so I'm going to be adding up all sides. So W plus 6 1/3 plus W plus 6 1/3. Down here we'll use this equation to find the dimension, so I'm going to start by going ahead and commuting my like terms next to each other. W plus W plus W plus W. Just using this equation from above, plus 6 1/3 plus 6 1/3. And all of this is going to equal to 30 feet of fencing. Now combine my like terms. 4W plus 12 2/3 is equal to 30. Start solving our equation. I'm going to add a negative 12 2/3 to both sides. $30 plus negative 12 2/3, negative 12 2/3. That adds up to 0, leaving us with 4W. And 12 2/30 minus 12 2/3, that should give me 17 1/3. And that's actually probably something I want to change to an improper fraction, considering I'm about to have to do some inverse operations over here. So I'm going to go ahead and change that to an improper fraction. 17 times 3 is going to give me 51, plus 1 would be 52 over 3. All right, dividing both sides by 4, well, we know that's the same thing as multiplying by 1/4, because we are going to divide fractions. This is going to be W times its reciprocal, 52 over 3 times 1/4. This actually we can break down as 13 times 4 to do some simplification beforehand, and we're going to get 13 over 3 is going to be our width, which if we break that down, that's going to be 4 1/3 feet for the width, which means the length, which is 6 1/3 feet longer. The length is going to be equal to 4 1/3 plus 6 2/3. And wait, is it 6 2/3 or is it 6 1/3? 6 1/3. And that's going to give me 10 2/3 feet for our length. All right, let's flip on over and look at a couple of problems that you're going to work on with your partners. All right, looking at this one, it says Nancy's morning routine involves getting dressed, eating breakfast, and making her bed. Nancy spends a third of her total time in the morning getting dressed, 10 minutes eating breakfast, and 5 minutes making her bed. And the remaining time driving to work. Nancy spends 35 and 1/2 minutes getting dressed, eating breakfast, and making her bed. How long did it take her to drive to work? Write and solve this problem using an equation. Identify if-then statements moved when solving the equation. Alright, so I'm going to help you out getting started a little bit on this one. It says Nancy spends a third of her total time in the morning getting dressed. Alright, so her total time is a value that we don't really know. We do know that Nancy spends 35 and 1/2 minutes getting dressed, eating breakfast, and making her bed. Alright, so we know that 35 and 1/2 minutes is going to be our total if we're adding up 10 minutes plus 5 minutes plus however long it takes her to get ready. So if we write x and we think about x as being equal to the time to get dressed, this can help us identify how much time it takes her to get dressed. So when we do this, we're going to combine our like terms. That's going to give me 15 plus x is equal to 35 and 1/2. Add a negative 15 to both sides. That adds up to 0. So that's going to tell me that x, how long it takes her to get dressed, is equal to 20 and 1/2 minutes. Alright, so her total time to get to work is going to be 3 times as much as that. So we know that her total time at work is going to be total time to get ready is 3 times 20 and 1/2, which would be 61 and 1/2. And so now if we take these 61 and 1/2 and we subtract away how much time she does doing all of the other stuff, then we're going to have our unknown value here. So she spends the rest of her time, so it's the 61 and 1/2 minus 10 minus 15 minus the 20 and 1/2 she spends getting ready. If I combine all of my negatives here, all of what's being taken away is going to be 35 and 1/2 minutes. Which leaves us with 26 minutes of drive time. Is our answer reasonable? Does this make sense? Alright, and finally looking at our last problem, the total number of participants who went on a 7th grade field trip to the Natural Science Museum consisted of all the 7th grade students and 7 adult chaperones. 2/3 of the total participants rode on a large bus, and the rest rode on a smaller bus. If 54 of them rode on the large bus, how many students went on the field trip? So, looking at this, we see that 2/3 of the total participants rode on the large bus. So that's 2/3 of the total participants. So we'll go ahead and say X is the total participants. Says if 54 rode on the bus. So 2/3 of the total participants, X, is equal to 54. Well, we know the total participants. If I really want to replace this, and I want to do this all in one step, 2/3 of the total participants. Well, the total participants, if we think about this as Y, would be students the total participants would be Y plus 7 adults is equal to 54. Alternatively, you could use this expression. So we have two different equations here. This one would find the total participants, and then we could subtract out the adults afterwards. Or we can go ahead and use this equation and go ahead and find for our value. So all at once. So I'll go ahead and do it this way. This is going to give me 2/3 Y plus 14 over 3 is equal to 54. I'm going to add a negative 14/3 to both sides, and so what I'm actually going to do is I'm going to go ahead and change this to a improper fraction with a denominator of 3. So it's going to be 2/3 Y plus negative 14/3 plus 14/3 is equal to 54. Okay, so times 3 over 3 is going to give me 162 over 3. And then we're adding a negative 14/3 to both sides. Two-thirds Y is equal to 148 over 3 multiplied by the reciprocal. Threes cross cancel. Y is equal to 148 over 2, which is going to give me 74. So one way we can check that is by doing it the other way. If I just want to find the total participants, I can use this equation. So I'm going to do that really quickly. 2/3 of X is equal to 54. Multiply by the reciprocal, 3 over 2. Cross cancel, cross cancel. This can be simplified to 27 times 2. That cross cancels. It gives me x is equal to the total of 27 times 3, which is 81. So our total number of participants would be 81. But we have 7 adults there, and the question asks me only for students, so y would be equal to 81 minus 7, which is indeed 74. So again, we can see that there are two methods, both using equations to solve the solution. One requires more work when solving the equation, one requires more work after solving the equation. So we can really think about that either way. Alright, flip on over to your alone time and check out the problems you've got there.